Hi, this is Mrs. Vrobel. This is part one of chapter 7, Ionic Compounds and Metals. Um, Today we're going to talk about ionic compounds, and you probably are wondering, well, where can I find ionic compounds? I actually have a container of, this is low-calorie G2. It's a thirst quencher, and it's kind of interesting when you look at the label. They talk about thirst quencher, they talk about electrolytes, and we're going to unpack what is an electrolyte. So when we're looking at conductivity of a compound, we're looking at charged particles that are essentially moving through a medium. And there's two types. There's metals. So we've talked about some elements that are metallic in character. And essentially it's like electrons moving through a pipe. Now there's what we call electrolytes. So that container that I just showed you contains electrolytes. And essentially these electrolytes that are in that product, they help conduct an electrical current. So yes, if I made a solution of that, and I'll do a demonstration where I show you electrolytes, what they can do, you could actually get conduction within that medium. Okay, so sodium chloride. We see sodium chloride everywhere. If you look at all the labels of the foods that you eat, you're going to find lots of foods contain sodium chloride. They know now through a lot of research that our taste buds respond very well to salt. And you may notice that a lot of the processed foods that you purchase have a lot of salt in them because it makes it taste better. Now with the salt, we are talking about a positively charged sodium ion, so Na+, and then we have a negatively charged chlorine ion. Do you remember, what do we call the negatively charged ion? Anion, okay, and notice it has an IDE suffix, okay, so the chloride ion has an IDE. Here are some very generic ions. Notice they're monoatomic, so that means there's only one. We're going to talk about more than one. We call them polyatomics. So monoatomic, you always change the element's name to IDE. So whatever the suffix is on the element, it ends up being IDE. So we go from bromine to bromide. Nitrogen is probably the one that a lot of people mess up on. This is nitride. And the same with oxygen. Notice that oxygen becomes oxide. Okay, you have to be careful of the ending. Even phosphorus, we go to phosphide. Sulfur, we go to sulfide. So you want to just train yourself, whatever the ending is, you're going to delete that and add IDE. Okay, so for ionic compounds, we know metals tend to form cations, nonmetals tend to form anions. We've seen that before. When you have a metal bonding to an anion or a nonmetal, we always call that an ionic bond, okay? So whenever you see a metal element with a nonmetal, just assume we're talking about an ionic bond. There may be exceptions to the rule, but most of the time we're talking about ionic bond. The ionic solid, or the material made up of the ions, it will be alternating pattern. So you're going to notice when we talk about covalent bonds, there's something different going on, and we'll get into more detail with the next chapter. Notice that when we're talking about ionic bonds, we're talking about empirical formulas. They aren't discrete molecules. So when we talk about covalent bonds, we're going to talk about molecules. Instead, with ionic compounds, we're talking about empirical formulas, and it'll make more sense in a little bit. When we look at their masses, we call them formula masses because it's hard to cut out a discrete unit of an ionic compound. They're kind of like alternating patterns. So we look at the formula mass, the lowest common denominator. Okay, so like I said, you're going to do those three that I checked off. Okay, so empirical formulas. empirical formulas, we're looking at potentially what we call polyatomic ions, and you will be given a chart of the polyatomic ions. So the good news is you don't have to memorize them. Polyatomic ions have two or more atoms together, and in that ion is an overall charge. So like ammonium has a 1 plus charge, phosphate, so notice it's phosphorus and oxygen, has a 3 minus charge. So that 1 phosphorus surrounded by 4 oxygen, it has a 3 minus charge. So you may see a positive charge. A lot of these polyatomic ions tend to have negative charges. Okay, so when you write the empirical formula, you cannot change the subscripts of the polyatomic ions. So for that polyatomic ion, let's just go back. That means here where you see the number 4, you can't change that. Same with ammonium ion. You cannot change that. You have to leave it at that. That's what makes it unique.